If you took a trip to outer space and you brought along your boombox because you love your music and you want everyone else to appreciate your music, you would be disappointed because, well, lo and behold, we can't hear anything without a medium, because sound cannot go through a vacuum. It needs matter. And depending on that matter and the physical properties of the matter, the speed of sound will vary. So if we try to send some sound through a solid, it will travel much quicker than through a gas. What's happening when sound occurs is that there's some particles, like if I was playing billiards, I'd shoot this cue ball and it would hit all of these. They'd relatively stay in place, and then this one would move forward. Same is happening with sound. I am propagating a disturbance, and it's traveling to all the air molecules, ultimately for my phone's receiver to pick it up. A thing about gases, even though sound travels slowest in gases, if we up the temperature and the air pressure, we can increase the speed of sound. For air, at about 20 degrees Celsius, the speed of sound is 340 meters per second. We could talk about the intensity of sound. It's the energy transported across an area per unit time. This is measured in decibels. We haven't worked in decibels yet, and we really won't dive much deeper into this topic, other than saying that the intensity is proportional to how far away the object is squared. This is an inverse square law. It comes up a lot in physics. Inverse square law. Can you think of any other times that you've seen it? Maybe for measuring out the force due to gravity, m1, m2 over r squared, inverse square law. The same applies here. If we're at a concert, you're some r away destroying your ear, and your pal is 2r away, well, this friend, the smarter friend, is feeling an intensity from the sound that's 1/4 what you're feeling. You can see that algebra there. It's critical that you guys are able to do this skill here, where you relate one term to another by figuring out what's changing in the scenarios. So see if you can make sense of that. Some examples that could cause a sound. Well, we could vibrate a string, vibrate membranes, vibrate metal or wood, vibrate air columns. You just need to cause some disturbance in a medium, and it will propagate. That causes a sound. So even if it's as basic as taking a rubber band and flicking it back, you're vibrating something, and we might be able to pick up on that vibration as sound. The next video is going to look at vibrating air columns, or vibrating the air particles within a column. We could look at open columns and closed columns and see how that works and how instruments produce a given frequency. That's all for now.